Well, welcome to another electronics video. This gives you a bit of an idea what to expect so you're not watching halfway in and realise it isn't what you want to see. In any case, I am in the 6-wheel drive ambulance at the moment in the field, but this was the delivery of stuff that arrived just before I left. So we're going to talk a bit about this. I have a Raspberry Pi 5 with 8GB of RAM, an active cooler, an NVMe adapter and a 6-port NVME SATA card. I don't know if these things are all going to work together, but at home I have about 52 terabytes of drives in a box running off a Raspberry Pi 4, and I'm thinking about going to Raspberry Pi 5. Those drives are just they're not running RAID or anything special, they're just plugged into a USB 3 hub running the USB to SATA adapters. So I thought this might be a slightly faster way of doing things. In either case it'd be neater anyway. But yeah, let's just assemble this and we might be able to test it in the field. Because in case you're interested, we are at a free camp at the moment. So we'll have to improvise. Alright, so I have de-virginized the Pi 5 box. Weird way of opening, makes it hard to reuse. In any case, I have 2 active coolers with this. This one came with thermal pads and some springs and some other stuff. This one has the springs captive and the official Raspberry Pi logo on it. I may end up using this one, I think. Might be a little bit easier to implement. They don't look a lot different. And I'm sorry about that funny flicking with the camera. That's that LiDAR autofocus thing that's happening since, you can see here, it does that. That's something that's changed with a recent update. So in any case, I think I'm going to go with this heatsink. Let's put these 4 things together. So here's the heatsink on, and it's 2 little snap clips you push through. This one appears to have screws with springs, or are they? Oh no, they might be the same little snap clips. I think it's pretty much the same thing. In any case, that one's on, and the thermal pads were already placed for me, which made things very easy. Now you'll have to excuse my improvised background and backdrop and whatnot. There's not a lot of room in here. One of the reasons I carry a Victorinox cyber tool here is because inside the bit holder here is 2 little steps that are exactly the right size for doing up standoffs, and also the screws on the end of like RS-232 headers and stuff, which for me is still a thing that I need to do. In any case, standoffs are in. Alright, now that's on. We'll put the ribbon cable on in a moment. Important to note is the 5-volt socket here. I didn't order the external power supply for that because this will be getting powered from the same supply. I actually have a computer power supply in my server that runs this, or that will be running this, and that will be wired directly to a 5-volt line. So I may even lift that connector off and solder directly to that. I'll find out if I have one of these connectors spare. I probably do. But this might not actually work to test in the field as is, but because it probably needs that 5-volt supply to run this card. But let's get the ribbon cable on and get our card installed. Alright, here's our little Frankenstein creation. We've got 6 SATA ports on a Raspberry Pi. Now, I don't even know if I can test this in the field. I do have a projector in here that is connected to a Raspberry Pi 4, which means I've got the mini HDMI output, but I think without this 5-volt connector we might be a bit stuck. But I'll have a scrounge around in my spare parts box and see if I've got one. I probably won't though. Is there anything in that box? No, there isn't. Okay, so I don't have spares. Oh, look at the cute little screwdriver they sent me. Alright, so yeah, this might sit until I get home, but in any case, I wanted to do the assembly in the field because patience is not really my thing sometimes. In any case, yeah, we'll see when I get home and see if this works. Alright, so a few days have passed and some mileage has happened and I'm back at the desk. I also have a new phone because the phone I recorded things on, I tried to clean it and it sucked water in under the camera lenses, so I had to remove them. And this camera element here is probably not going to clear up properly. We'll find out. I filled it full of alcohol. Anyway, $2,000 uncomfortable dollars later, I have a new phone. so I can record this. In any case, I have made some mods to the power connections here. The Raspberry Pi I used in my file server, I actually directly soldered to the GPIO pins to backfeed it. That does bypass some of the safety measures in place on the Pi, namely this little chip under here. So I am wiring directly to a Molex plug, which fits what the power supply I have in the server at the moment. I'm using two separate grounds, and I've connected to the 5V in on the NVMe adapter as well to supply extra power to this. I have not tested this yet. I bought a nice Samsung Evo Plus card here, a slightly faster one than average. I know this faster than that again, but this should be suitably good for the job. I've plugged the fan in. We should be right to go. Okay, and this is my file server in an old Paycom DVR rack mount unit, and we've been copying some stuff across here, and we've run out of room anyway. We have to pull a 5 terabyte drive out and put a 14 in there, which is hiding under there. We'll crack it out of its shell later. The 5 terabyte is in its own casing, and it's got an integral drive. It's not just a desktop drive. It's got its own Western Digital control board on it. That's why it stayed in the case. Anyway, let's drag this out after we shut things down and have a look inside. Okay, we have powered the system off. Let's very carefully lay this down at ground level. Pull out and slide down. Okay, I should lock that front bit. Here's our top cover. Now we can have a good look in here, and I'll explain a few things and I get questions. Excuse the foot of the tripod here. So this is our Raspberry Pi 4. We have a USB hub here. We have another USB hub over this side as well. And this is the Western Digital 5 terabyte we've got to take out. This is a relay card in here to run the various fans around the place. We have 4 drives in here. We have our 5th there. I'm hoping that this guy can plonk straight in here. What I want to find out firstly is if this will even work. So I figure we're going to co-opt our little Molex plug here and just plug this into the existing connections. See if we can make it work and set up SSH and have a play around with it. I've put Librelec on here, and so yeah, I think we'll leave everything in situ. Plug in, put an insulator under it, and see if it fires up. Alright, now I've fairly carefully checked my power connections. I'm just going to double check it again, and I'm glad I did. Let's unplug this. So I depinned this plug. I forgot the grounds are in the middle. I need to swap those two around. Always triple check, guys. Yeah, I've had a long day of spending money I didn't want to spend. So let's get the depinning tool here and try and save ourselves a few more bucks. That one's got to go in there fairly firmly. Pull you out. Pull you out. I haven't looked up the Molex standard for these. But whenever you depin a plug, this is a risky run. Okay. Let's check our colours. Okay, red is for 5 volts. Black is for ground, yellow is for 12. We're tapping off 5 volts off that one. Doing pretty good. Now, can I get this Molex plug to go back together now? That looks to be fairly good, except that pin has pushed back through. We'll push it in like that for now. That went click. That's good. Okay, so red to red, black to black. Okay, we checked the shroud and the ground of that, and the ground on this and the ground on all these things will correspond. That's good. We didn't appear to have a short. We've just got our front panel USB connectors in here and network. Okay, and also HDMI. Alright, we've got things set up. I still need to adjust the time zone and fix an IP address in here. It is decidedly nippier than the old one, probably because of the faster SD card. But also I'm only using 216 mega RAM right now, and not much on the CPU either. So this could be well. Anyway, what we want to do is we'll fix our IP address. We've set up SSH, and I'll connect to it and see if I can do an LS USB or probably not LS USB, there's another command I forget the name of off the top of my head, but it can tell me what hardware is detected. Apparently SATA is native to the kernel, but maybe not with LibreLec. So we'll see what we can do with this. Alright, we're back on the desktop machine and we've connected via SSH, and we're all pretty good. So let me dig up the commands we've got to run. Alright, so I ran LSPCI to see what's on the PCI network, and I've got a PCI bridge Broadcom, which is pretty standard, and I've got an Ethernet controller. Not seeing my NVMe device. Interesting. Okay, so I've got to enable it in the config flash, in the config.txt file, but I'm having a bit of a hard time doing this in LibreLec because it's pretty locked down. So let me do a bit more homework. Never mind, I found it. Flash here is mounted. Normally this is like an ext partition, and the FAT32 partition in here where the config.txt file is located. That's what I'm looking for, so let's get Nano on the job. So my standard config is all here, lots of stuff commented out, HDMI, CSC, ignore is in here. We may enable that because it is on a CSC enabled TV, and we do want that. So there's GPIO stuff we'll engage later because I'm using GPIO to run fans. But I need to work out what I've got to do in here to enable the PCI Express. Alright, so I'm adding DT param PCI X1. Apparently I can also do DT param NVMe as well. I may actually do that because of what I'm adding to it. And there's a few other things here for PCI Gen 3 and all that sort of stuff. I think I'm going to set it to Gen 2 just to start with. I can play with Gen 3 later. Alright, so I managed to run dmesg and grep the PCI. Now I've got to go through this and see if the device I'm looking for is in here. I need to read through this slowly. Now I've got down to this line here with the Broadcom PCIe forcing Gen 2 and PCI host bridge to bus, and a link up at 5GT, the PCI by 4. That's the internal PCI port, I think. I'm seeing PCIe port here, enabling device, so it's enabled the PCI port, set up an IRQ and enabled an IRQ. I don't see, I've got the wireless receiver here, I don't see the other device. Well, I guess there's really only one way to find out if it works. Throw some SATA leads at it, we'll plug a drive in and see what happens. Okay, so down in here I've plugged in SATA power and a SATA lead, unplugged the USB thingy and propped precariously out of the way. Let's hit our power button, see what happens. And this thing is fast. It took me just as long as it took to say, let's see what happens, to see if it would work. So I'm not seeing another drive in here. It hasn't showed up. We'll check SSH and see what shows up on that. Alright, I'm going to try a different disk image on it and see if there's better support with, say, native Raspbian. I'll do it with a recommended one. So we are going to choose our device here with the Raspberry Pi 5. We're going to choose the 64-bit Raspberry Pi OS and that device. We're going to do that, and alright, I'll save you some time with the process that I went through here. So I got the Raspberry Pi OS running. It didn't see the drive. However, what it did tell me is that it's restricting power to peripherals because the power supply can't supply enough. And that would be because it's not detecting all the other pins of power. We've just got standard power on here. So I have an official Raspberry Pi power supply. We'll see if that does it. We'll see if it's a power supply problem. Alright, so it's still warning me of this even on the official supply. And some of the issue we have is that this hat card, I was trying to pick power up off that, so I had to disconnect that as well. So it might be difficult if the hat is not powered. Now, just for the sake of testing, I also plugged in this M-keyed SSD into the NVMe slot as well, booted everything up, did an LSBLK, couldn't find anything. So yeah, I think something's wrong with the config. Okay, so I've been playing with a bunch of things, including different NVMEs and everything, and it occurred to me I can probably test if this is working by plugging it into my USB enclosure. So if we did this, we can see these lights should light up if it's being detected. Now what I found is that none of this was being detected. I did a bit more homework, and this is not necessary unless you can't supply enough power. I have checked and reseated this a couple of times to make sure that I absolutely have that round the right way, and I believe I do. There's not much else I can really think. There's not a lot of electronics between this and the board, so I can say it's probably just that I'm not enabling the PCI Express port on here. So I do a little bit more homework, but I think it's just a configuration issue. Okay, so I had a bit of an idea that I keep getting a low power warning, and even though I'm using the official power supply, it keeps going, we're going to limit power to the peripherals. I'm assuming maybe the PCI Express is considered a high power peripheral. So I'm going to force the high current state and see how it goes. If that lights up, then I'll hook up the extra power connectors to that board again anyway. Let's see how this goes. Alright, that didn't work, so I'm going to try and set it to 5 amps. See what happens. Okay, so I might have been in the wrong area to put the max current. So we're going to edit the eprob in boot.conf and see how that works. Haha! Now we set max power, it's all lit up. Haha! And now when we run LSPCI, we actually see an extra thing here. Ethernet controller, Broadcom bridge, SATA controller from ASMedia, ASM 1166. That's our little chip. So we had to enable high power mode. We are using the official supply, but I want to run off my little adapter here. So I'll be rerunning the cables off this, because obviously we need a bit of extra power on here. Anyway, progress. Okay, a few things have happened, and I've been off and had lunch in the meantime. I have reinstated the power to this card. Because we have overridden its power limitation technology, it means it could potentially burn out that ribbon. It won't stop until we hit about 5 amps. So definitely we need that. This is really the only accessory we're going to run on this that pulls auxiliary power, and it's got its own power line, which should be good. Comes off the 5 volts off the power supply here, which should be able to give us a fair amount on the 5 volt rail. Plenty more, I think. 5 volts, where are we? 5 volts, 22 amps. We've got enough to run all of this stuff. In any case, we need to test that this will work on a drive. We'll do that now. We'll grab one of our SATA leads here. We'll test if it works. I've also changed back to Librelec. Now I'm pretty sure that max power setting that I set up, I think that's written to the BIOS. So we'll see when we fire this up right now if that lights up. I'll turn the screen on in the background, but we should see a little blue light come up here. Yep. Okay, so that high power setting has been written to the BIOS. It's independent of the operating system. That should be fine. I'll have to set this up, and what it does mean I'll need to do is go in and enable the PCI port in the config file. That's not too hard to do, and yeah, we'll go back from there. Alright, we've modified the config.txt to enable the PCI Express board. I'm getting lost with acronyms. It's like being in the army all over again. Let's see if we can blow anything up by turning the power on. I forgot to double check. I had depinned this and repinned it, but yes, I did get the colors the right way around. I'm glad I'm not feeding 12 volts directly into it. That would have been bad. So I don't appear to have drives available, not from that one hard drive. So I do, if I go through Zoom here so I can be lazy, there is a little blue light there. So that tells me something's working. Alright, so back in the other room over SSH doing an LSPCI, we can see the ASM 1166 serial controller. So it does recognize it. Got a bit of mucking around to do, I think. So I came to the conclusion that either Librelec didn't have PCI support or something else was happening. So I've loaded back again Raspbian onto the disk, and I'm seeing some PCI port failures. I've got to go do some homework on that. And the AHCI ports are unavailable apparently, so let's go and work this out. Okay, so after much mucking around, I found out I can't update the firmware on this while it's on a USB adapter. It has to be direct on an NVMe slot. Removed my secondary MP600 and jerry-rigging this in because I can't be stuffed getting the screw on right now. We should be able to update the firmware on this. I think that is the problem with it talking to the Raspberry Pi 5.